conclusions and evaluations. So our conclusion, our data has helped us to identify how velocity on the River Charmerdale has increased as we have moved from source to mouth. Why is that? Why has velocity increased moving from source to mouth? Well, more water's entering the main channel. More water means more erosion. More erosion leads to a wider, deeper and smoother cross-section, which reduces friction and increases velocity. There were some anomalies though. In the upper course, we had a period of whitewater turbulence due to the geology caused by rapids. That led to higher than expected velocities, and that was because of a local factor, geology. And by the mouth of the river, velocities where we were expecting them to be at their fastest actually slowed down. Why is that? It's because at the mouth of the river there's an estuary. So you've got the flow of the river meeting the tide of the sea, and that slows down the velocity in the River Charmerdale where we would be expecting velocities to be at their fastest. Let's evaluate. So evaluation, the what went wells and the EBIs. So the what went wells in terms of our investigation. We studied 10 sites in the River Charmerdale moving from the source to mouth along the long profile in the upper, middle and lower course of the river. That has provided us with a fabulous representation of the river's velocity. What's the EBIs? I always like to think more data means more accuracy. Wouldn't it be good if we could study changes in velocity on the long profile of the River Charmerdale in spring, summer, autumn and winter? Why? Well, in the summer, discharges are very low, so velocities are very low. But in the winter, when it's very stormy, velocities are very high because discharges are very high because there's a lot of rainfall. Obviously, this is impractical to be going on a field trip 4 times a year, but in theory, that would provide us with an excellent representation of the River Charmerdale's annual variability in velocity.